Hi everyone. Today I'm going to talk about artificial intelligence, which is a door opener to a new era in image processing. At first, I would like to tell you something about the different terms in artificial intelligence, which might be confusing to somebody. Second one I want to talk about is comparison between artificial intelligence and rule-based image processing. Therefore, I will show you some examples. And then, which is the main part of this presentation, is how you can master your first AI-based project. So stay tuned for this one. And at the end, we are going to make a short summary of what we learned today. So let's start with the disambiguation of artificial intelligence. AI is more of the umbrella term around all the other terms, which contains, for example, machine learning. Machine learning is still based on classic algorithms, which are able to learn by themselves. So they can solve specific problems which are not able to solve with rule-based image processing. They can learn from sample data and make an inference, so apply the learned data on new data. Then we also have deep learning. Deep learning uses neural networks. It's also called artificial neural networks or deep neural networks. That's why we call it DNNs. The last one is the CNN, convolutional neural networks. Those networks are used for image processing, so this is the most important part for us. Now I'm going to show you the difference between rule-based image processing and AI-based image processing. Rule-based image processing usually is coded. So you need to have sample image data, you need to have specific knowledge how you can apply the algorithms to your image data, and then you need to code. You need to code a lot. This is why the process of rule-based image processing is can take quite long. And after that, you can deploy it on a computer or another embedded platform. In comparison to that, we have artificial intelligence. So the stairway at the beginning can seem quite higher than with rule-based image processing, but it can be much shorter. So at first, of course, we again need sample data. And then you will need some specific AI knowledge. And for the training, you will need a framework like TensorFlow or Keras or Caffe or PyTorch. And then you can train the neural network. Therefore, you will need a training platform, hardware, like a GPU or other systems. Sometimes it can also be solved in the cloud. And after the training, we will get the CNN, which we can then deploy on a system. Also an embedded system or a PC. So you can also make it shorter with specific tools, like the one from IDS, which makes it more easy to train a neural network. But you will learn more about this in another session. So in this case, to compare those two approaches, I have a sample application for automated charging of electric vehicles. To make it more easy to explain, I simplified it with a socket detection. In a classic rule-based image processing algorithm approach, you will first need to segment features and analyze those blobs, those segmented features. In this case of a socket, you will search for a big circle and the two holes in the middle, which are two smaller circles. And then you can say it's a socket. So like in our example, you you can identify the five sockets. But what if it's another socket with another color, other shape, like the one from the US? Is it no socket then? Or if you have a pig in the image, is it a socket? You can try to plug in your mobile phone into a pig's nose, but it probably won't work. So we need to describe more routes. In the approach of artificial intelligence, this can be much easier. So in reality, there are many different types of sockets from the cars to charge. We have different environment conditions, we have different backgrounds, we have different colors of the cars, and also the socket look differently. So with artificial intelligence, you can simply tell the network what it is. In our case, we have different types of sockets from different countries and colors. And then we can train a neural network. And after training, we can show the network a new image. It can do the inference, and the result, in this case, will be a US socket. Okay, let's come to the main part. Mastering your first AI-based project. So there are two main things you need to do. You will need to do to find the right task, and you will need to do a proof of concept. Without a proof of concept, you will not be able to see how easy it can be or what kinds of tasks can easily be solved in your applications. And therefore, it's necessary to start small, to search for a small project which you can easily solve with artificial intelligence. You need to move fast, gain quick results. It doesn't matter if the results are good or bad, because you learn from this. And if you gain good results, you need to share this success to motivate your employees and the people working in the project. It's sometimes also good to have partners which are already familiar with artificial intelligence. And here I have an example of growth inspection of Cress. So this is a small proof of concept, easily set up, and we got quick results, and the results were really good. And now we were able to deploy it in the field, in a greenhouse or something else. So the most important thing for the beginning of artificial intelligence is to find the right task. Here I have an example of what the AI is capable of. So it's really good to handle variable backgrounds. It's also really good to see the difference between high varieties, and also to see the difference between really similar features. This is really complicated for classic rule-based algorithms to identify. To sum this up shortly, not really suitable for artificial intelligence are tasks that are quantitative decisions, like measuring a distance or reading a barcode. Really suitable applications or tasks are qualitative decisions, like this piece has a crack or there's something missing. Here I have a list of tasks that are typical for qualitative decisions with deep learning. First, we have classification. So this uses the whole image content to classify what is inside. You can easily classify if something is good or bad, or differentiate between different pieces. The second one is object detection. It already says what it is. It detects objects in an image. You can also locate them in the X and Y axis or rotation. And the last one is segmentation. For segmentation, you can basically classify each pixel of the image and say that this area is an apple, for example. I will show you an example later. So those three tasks are called, or for these three tasks, training is used as supervised learning, which means that you need to annotate each image for the training and tell the network what it is. There's one other example, which is anomaly detection. This is called unsupervised learning because it only handles good sample images. Okay, now I have some examples. In this case, we have a multi-classification. So we have several ROIs on each parking lot, and we can classify if there's a car or not. This is a nice example because we have different environment conditions. We have different cars, which always look other than other cars. And in this case, we can calculate the utilization of the parking lot. The second example is object detection. Here we can detect different objects and locate them. So we can, for example, count how many cars are in the image. And the last one is segmentation. Here you can see that the driving area and the parking area are segmented in different colors. And we can then, for example, analyze if somebody is parking in the driving area. In this example with the gear inspection, we have also a multi-classification with okay, not okay tasks. So here we can see that 7 gears are okay and 1 gear is not okay. So one tooth is defect. But with multi-classification, we can also solve another task, like you can see now. So here we can count how many gears are light gray, how many gears are dark gray or blue. So in this example, we have a location detection where we can also tell the rotation of the objects. So this can be used for automated assembling with robots. When you have the plus-shaped shaft and want to stick it in, you would need to know the rotation of the gear. And the last one is segmentation. This can be used for sorting, for example. We can differentiate between the different gears, sizes, and also on the bottom, those two gears are quite close together, and with classical rule-based image processing, it can be that the algorithm will see it as one part, but the artificial intelligence can see that there are 2 parts. So in my last example, I have industrial food packaging example. We have single classification, so we have the whole image content classified, and here you can see that the arrangement is not good because the one apple on the bottom right side is showing upwards. In this example, we have a classic object detection. We can detect 6 apples and count them, and this is what is necessary in this application. We need to see if all of the apples are inside the tray. And the last one in this case is anomaly detection. So we can see if there are defects or anomalies in the image In this example, the training was already trained, the neural network was only trained with good images, with a good foil of the packaging, and here the neural network detects some damages. Okay, now we learned some things about, basic things about artificial intelligence, and now I would like to sum this up a little bit. What did we learn today? The first thing is convolutional neural networks, also called CNNs, are used in image processing. Artificial intelligence increases the possibilities of image processing, which means it does not replace existing systems and solutions. It also, it more is used in addition to classic solutions and can solve different problems which cannot be solved with other solutions. It is the perfect fit for qualitative decisions, which is really important to find the right task. And yeah, of course, you need to be start small, to move fast, and share your success. Those are the 3 most important things with your first AI project to motivate your people to broaden your knowledge and use it in more projects. So if you would like to learn more about the IDS solution with artificial intelligence, you can see my next session, which is about IDS Next and its possibilities. Thank you for being here, and goodbye.